Hi, welcome to the Olympiad Geometry Club. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. Today we're going to continue our study on the geometry treasure. We will talk about the Fermat point. This is a point actually relates to many other triangle points, and we can get so many interesting conclusions, theorems. But for this video, I will just introduce some basic theorem of the Fermat point. The Fermat point comes from a question that raised by the Fermat. It's about to find a point on the plane. Right, on the plane, we have triangle ABC. We want to find a point P. Make the distance summation PA plus PB plus PC to be the minimum. The question is how to find this point P. And now let's learn about it. The theorem 1. If inner angle of triangle ABC are all less than 120 degrees, P is any point in the plane. The point O subtends an angle of 120 degrees at each of the three sides. Then OA plus OB plus OC less or equals to PA plus PB plus PC. Equality holds if and only if P coincides with O. So basically, the first theorem is saying that in this triangle ABC, if all inner angles are less than 120 degrees, then we can find such point O that angle AOB, angle BOC, and angle COA all of them are 120 degrees. And if we can find that point O, then we should prove, or we should have the conclusion that OA plus OB plus OC is less or equals to PA plus PB plus PC. P is any point on the plane. Okay, O is a point we find. It has a minimum distance summations of the three vertices. So the question is, how can we find this point O, and then how can we prove this, right? So we break the problem or theorem into two steps. The first question would be, how can we find this point O? This point O has a property that make angle AOB, angle BOC, angle COA, all of them to be 120 degrees. So it is obvious that if we can find a point make angle AOB and angle AOC to be 120 degrees, then angle BOC is 120 degrees. Then the thing is easier to think about, because this point O can be taken as an intersection point of the circumcircle of triangle ABO and triangle ACO, which means if we have the circumcircle of the triangle AOB here, right, if we have the circumcircle of the triangle AOB and triangle AOC here, it's easy for us to recognize that the angle, we can just choose any point on the arc AB, we call it D, and on the arc AC, we call it E, right? It's easy to find that angle ADB equals to angle AEC equals to 60 degrees, which means we just need to find the circumcircle, then we can find the intersection point that is O. So what we can do here is to just make equilateral triangles from AB side and AC side. Now we have triangle ADB and triangle ACE. They are all equilateral triangles. Then we can find the circumcircle of these two triangles, right? And circumcircle of the triangle ACE. Now we know that the intersection point O satisfy the conditions that angle AOB equals to angle AOC equals to angle BOC equals to 120 degree. Okay, now we find O. How can we prove that for any point on the plane? Let's call it P. That OA plus OB plus OC is less or equal to PA plus PB plus PC. It's easy to observe that we have the OA plus OB plus OC. So if we think about way to translate it to the area calculation, it would be easier. So what we can do here, let's say we already found the point O, okay? Let me see, point O, something like this. Right, what we can do is that passing through point A, we can do the perpendicular line of OA. Right, similarly, passing through point B, we can do the perpendicular line of OB. And passing through C, we can do the perpendicular line of OC. And let's call the new triangle we have is DEF. Right, because angle DAO is 90 degree, angle BOD is 90 degree, we know that AOBD are cyclic, which means the D is also on the circumcircle of triangle AOB. So the angle ADB is 60 degree. Similarly, we can get the conclusion that angle AFC is 60 degree. So we know that triangle DEF is an equilateral triangle, which means OA plus OB plus OC times half of DF, for example, that's the area of the triangle DEF. Right, now we think about a point inside of the triangle DEF, we call it P. Then the area of the triangle DEF equals to the area of triangle PDE plus the area of triangle PEF plus the area of triangle PDF. Right, if the point P is outside, let's call it P prime, then the area of triangle DEF should be less than the area of triangle P prime ED plus area of triangle P prime DF plus the area of triangle P prime EF. Right, which means from here we can have the conclusion that the triangle the area of triangle DEF is always less or equals to the area summation of the triangle PDE plus the area of triangle PEF plus the area of triangle PFD. Right, this holds in all the cases. So how about this one? We can calculate as it also less or equals to half of, so the area of triangle PDE, that's DE times, let's say PB, right? it only equals to DE times PB if PB is perpendicular with DE. Similarly, we can have half of EF times PC and half of DF times PA, right? And this one equals to half of DF times PA plus PB plus PC. Therefore, we get the conclusion that OA plus OB plus OC is always less or equals to PA plus PB plus PC. Right, that's for the case of that all inner angles are less than 120 degrees. Now let's look at the theorem 2. In the triangle ABC, if angle BAC is larger or equals to 120 degrees, P is any point in the plane, then AB plus AC less than or equals to PA plus PB plus PC equality holds if and only if P coincides with point A, which means that in the case that the triangle ABC has an angle BAC larger or equals to 120 degrees, then A is a Fermat point, right? We want to prove that. For this case, let's just think about we can break this into two cases, right? The first case would be angle BAC equals to 120 degrees. If angle BAC equals to 120 degrees, then we have the triangle like this. I will have another point P. So this is obvious, right? We want to prove that A is a Fermat point and this is already 120 degrees, so it's easy to think about. We just need to find a line that make BAD equals to 120 degrees, right? So we find this triangle here, then we know that A is a Fermat point of the triangle BDC, which means we have AB plus AD plus AC is less or equals to PB plus PD plus PC, right? So we move this one. On the right side, we have AB plus AC less or equals to PB plus PC plus PD minus AD, right? PD minus AD is always less than AP. So this one is less than the summation of PB plus PC plus PA, which means we get AB plus AC is less or equals to PB plus PC plus PA. Okay, then for the case that angle BAC is larger than 120 degrees. BAC is larger than 120 degrees, so we can think about the case that BAC is here. And we know that this angle is larger than 120 degrees. We also have a point P here. We can connect PB, connect to PA, connect to PC, and we can find 120 degrees now. Make angle BAE equals to 120 degrees, and then we connect BE. Right? So based on the 120 degree case, we know that A is a Fermat point of the triangle BAE, which means we have AB plus AE is less than or equals to PB plus PA plus PE, right? And we know that AC plus CE is larger than AE, right? AC plus CE is larger than AE, which means AB plus AC is less than AB plus L, right? Let's say equals 2 in the case that C and E are the same point. Okay, so AB plus AC is less than AB plus AC plus CE, which means it's okay less than AB plus AE, less than PB plus PA plus hold on, something wrong. No, we cannot do this. Hold on. Yeah, we actually can directly plus CE from both sides, right? So AB, based on this one, AB plus AE is less than or equals to PB plus PA plus PE. We can just add AB plus AE plus CE less than or equals to PB plus PA plus PE plus CE, right? And because AE plus CE is larger than AB plus AE plus CE, AE plus CE is larger than AC, so we have this one. Then we have this one, and PE plus CE, which is PC. Now we get the conclusion that AB plus AC is less than or equals to PB plus PA plus PC. Okay, that's theorem 2. And theorem 3. If point P is a Fermat point and max ABC less than 120 degrees, that means the inner angle is less than 120 degrees. Let PA equals to X, PB equals to Y, PC equals to Z, and then we can calculate X, Y, Z as a function of BCA and lambda, which we have lambda squared equals to half of A squared plus B squared plus C squared plus 2 squared 3 times S. S is the area of the triangle ABC, and which means S is a function of ABC, so lambda is a function of ABC. Basically, we want to find the function of X to ABC, right? Okay, now the question is like this. We have triangle ABC here, we have Fermat point P, and we know that P is X, PB is Y, PC is Z, and this is A, this is B, this is C. We want to find the relationship as X equals to FABCS, right? So first thing we can think about is that we already know this is 120 degree, this is 120 degree, and here the angle BPC is 120 degree. We can use the cosine law, which we have C squared equals to X squared plus Y squared minus 2xy cosine 120 degree. Similarly, we have A squared equals to Y squared plus Z squared minus 2yz cosine 120 degree. And B squared equals to Z squared plus X squared minus 2xz cosine 120 degree. And the cosine 120 degree is minus 1 to 2. So we can rewritten this as x squared plus y squared plus xy, right? And this one is y squared plus z squared plus yz. This one is z squared plus x squared plus xz. Now we have like c squared, a squared, b squared, and x squared, y squared, xy, all of these. And we know that we want to eventually prove that x equals to some ABC with lambda. Lambda is this one, right? So we need to figure out how to decouple the xy, yz, zx with x squared, y squared, z squared. Think about how can we get the xy. That must come from something like x plus y squared, right? We get xy. Then we can think about let me see. Yeah, that's right. We can think about the S of the area of triangle, right? S is the area of triangle, which is the area of APB plus area of BPC plus the area of CPA, which is half of XY sine 120 plus half of YZ sine 120 plus half of ZX sine 120. So it equals to square 3 divided by 4 xy plus yz plus zx, right? Which means xy plus yz plus zx equals to 3, actually 4 square 3 divided by 3s. Right, that's what we have for the s. Now we can think about how we get this xy term, right? So because we have xy plus yz plus cx, so if we do x plus y plus z squared, right, it will include the x squared, y squared, z squared, and some x, y, z, zx. You know, we can then eventually represent with the a, b, c, and s. Let's look at it. So x plus y plus z squared equals 2. X squared plus y squared plus z squared plus 2xy plus 2yz plus 2zx, which equals to half of a squared plus b squared plus c squared plus 3 by 2 x y plus yz plus zx, right? That equals to half of a squared plus b squared plus c squared plus 3 by 2, this one is this one, so 4 squared 3 divided by 3s, so it equals to half of a squared plus b squared plus c squared plus 2 squared 3s, which is lambda squared in the problem set, right? So it equals to lambda squared. Then we know that x plus y plus z equals to lambda. Now let's look at what we are looking for. We want to prove that x equals to b squared plus c squared minus 2a squared plus lambda squared divided by 3 lambda. Basically, we want to prove that 3 lambda x equals to b squared plus c squared minus 2a squared plus lambda squared. Then we can directly calculate the right part. So b squared plus c squared minus 2a squared plus lambda squared. What is lambda squared? Lambda squared is this one, right? That is a half of a squared plus b squared plus c squared plus 2 squared 3s. So this one equals to 3 by 2 b squared plus c squared minus a squared, right? And plus 2 squared 3s. Right, so this one equals to 3 by 2 b squared. B squared is z squared plus x squared plus xz. So we can have z squared plus x squared plus xz plus c squared. C squared is x squared plus y squared plus xy, and minus a squared. A squared is y squared, z squared, and yz plus 2 square 3s. Right? That's what we have. So it equals to 3 by 2. What's inside z squared? Cancel. Y squared cancel. And what's left? X squared plus xz plus xy minus yz. And plus 2 square 3. S. What is S? S is square 3 by 4 xy plus yz plus zx. Right? So we have 3 by 2 x squared plus xz plus xy minus yz. And think about here, we have 3 by 2 as well. So directly bring this in, xy plus yz plus zx equals to 3 by 2 x squared yz cancel. So we have wait. Here we have 2x squared, right? 2x squared. So here 2x squared. Here we have 2zx and 2xy plus 2xz plus 2xy. So it equals to 3x x plus y plus z equals to 3x lambda. Okay? So we prove that x, the yz are the same. Then we just proved this is true. Now let's look at corollary 1. We want to prove that x to y to z equals to sine a plus 6t divided by sine a, 2 sine b plus 6t divided by sine b, 2 sine c plus 6t divided by sine c. Right? We want to calculate for x to y to z. And we know that x to y to z can be rewritten as b squared plus c squared minus 2a squared plus lambda squared. 2a squared plus c squared minus 2b squared plus lambda squared. 2a squared plus b squared minus 2c squared plus lambda squared. Right? Basically, we just want to find the ratio of these three terms. That's right. So now let's think about what we get here. Right? So we have b squared plus c squared minus 2a squared. One thing that remember, we want to find something related to the sine a plus 6t, right? Which means we want to find something related to sine and cosine, right? Sine a and cosine a or something like that. Sine 6t, something like that. We want to relate to this one, then it's easier for us to calculate. Which means that we want to reform these three terms into the sine or cosine form. We bring them in, right? Okay, let's look at this one. We have b squared plus c squared minus 2a squared. It reminds us the cosine law, right? In the cosine law, we know that a squared equals to b squared plus c squared minus 2bc cosine a. Right? Which means 2bc cosine a equals to b squared plus c squared minus a squared. Right? And remember this one, the b squared plus c squared minus 2a squared plus lambda squared, we already simplify it to the b squared plus c squared minus 2a squared plus half of a squared plus b squared plus c squared plus 2 square 3 s, right? So it equals to 3 by 2 b squared plus c squared minus a squared plus 2 square 3 s. This square 3 reminds us of sine 60, right? So we get here it equals to 3 by 2 b squared plus c squared minus a squared. That's 2 bc cosine a, right? And also plus 2 square 3 times s. S would be half of bc sine a, right? So what we get here is 3 bc, hold on. We can do this, right? We can do let's just expand a plus 60, right? It equals to sine a cosine 60 plus cosine a sine 60, right? So it equals to sine a times half and plus cosine a times this one, right? So in the cosine a, we actually want to square 3 by 2. Right, so that means in the cosine a, we want to square 3 by 2. So let's extract 2 square 3. Right, 2 square 3, and now we have square 3 by 2 bc cosine a plus half of bc sine a. So it equals to 2 square 3 bc half of cosine a, square 3 by 2 cosine a plus half of sine a, which equals to 2 square 3 bc times sine a plus 60. Right? So for now, we get the conclusion that we can simplify x to y to z to be 2 square 3 bc sine a plus 60 to 2 square 3. So x is bc, right? X related to a, and then we have bc here. So y relate to the b, which we have ca here, and we have sine b plus 60, and 2 square 3. Z related to c, so we have ab here, and sine c plus 60. Right, we can divide by ABC for these 3 terms. Then we, and also 2 square 3, we can cancel them. So we get it equals to sine a plus 60 divided by a, 2 sine b plus 60 divided by b, 2 sine c plus 60 divided by c. And we know that a to b to c equals to sine a to sine b to sine c. So this one equals to sine a plus 60 to sine a, and sine b plus 60 to sine b to sine c plus 60 to sine c. Right, we just prove that x to y to z equals to this one. Okay, corollary 2, the area of the S1 to S2 to S3 equals to, the flip of x, y, z. S1, S2, S3 are the area of triangle BPC, CPA, APB. So it's obvious, right? The area of triangle BPC is half of YZ sine 120, right? And when we form the ratio, YZ can be YZ divided by XYZ, so it's actually 1 over X to 1 over Y to 1 over Z, which is sine A to sine A plus 60, sine B to sine B plus 60, sine C to sine C plus 60, right? So that's very straightforward. And for the corollary 3, I want to make it to be a homework. It's very interesting. It's not difficult, but it's just a little bit of calculations here. So R and R are the circumcircle radius and the incircle radius. A2x plus B2y plus C2z larger or equals to 6 square 3 R to R, right? So basically just a very short hint that we know that A2x plus B2y plus C2z larger or equals to squat ABC2 XYZ, right? So you need to find the relation of ABC and XYZ to R and R to prove that. Okay, this is actually very, very easy, so just leave it as a homework. Okay, so for today's video, we introduce theorem of Fermat point. Basically, these are the concept of the Fermat point. It's not the conclusion from the Fermat point to relate to other points. And we will introduce more about the Fermat point and other point in the next video. Okay, see you in next one. I hope you like this video. See you in next one. Thank you.